Hello, it's day 2 of Math with Patrick. We're solving the second question in this math calendar. And today I'm joined by a very special guest, my cat. His name is Quill. He'll be helping out with the math today. All right, let's get into it. So right now I see that we have a fraction and there's 4 terms in the fraction. Looks like we're supposed to plug in some value of x that's positive and get 5.41. Now, maybe this is an exact value or maybe it's rounded. I'm not quite sure. And just like before, the answer is already in the corner. It's today's date, the 2nd. But I'm going to assume that I don't yet know the answer and work through what it might look like to solve this problem without knowing that the answer is 2. So the first thing I do is, well, maybe I'll just plug in the first whole number after 0. So I'll try x equals 1. If x is 1, then I have an 8 plus 125, because anything to the power of 1 is just itself. And then a 20 plus 50 in the denominator. Adding the numerator, I get 133. And adding the denominator, I get 70. And already right now, I can kind of tell that this isn't going to get 5.41. I know that if I round up, I get 140 in the numerator. And I can tell that 140 divided by 70 is 2. So if this is 2, then this number is a little less than 2, and so there's no way that this could be 5.41. So x equals 1 doesn't really seem to work, so let me try the next number. And I would just try 2 next, honestly, because it's just the next number after 1, and then maybe I'd figure out some pattern here. So let's try it when x is equal to 2. And I've memorized a few of my square numbers, so I know that 8 squared is just 64. I don't know what 125 squared is off the top of my head. I know that 2 times 2 is 4, so 20 times 20 should have 2 more zeros. And then similarly, I know that 5 times 5 is 25, and so 50 times 50 should also have 2 more zeros. Now, let me just do that 125 squared down here, and I'll just do some nice classic long multiplication. Let's see, 5 times 5 is 25, 5 times 2 plus 2 is 12, 5 times 1 plus 1 is 6. Here's a placeholder 0. 2 times 5 is 10. 2 times 2 is 1. 2 times 2 plus 1 is 5. 2 times 1 is 2. Here's 2 placeholder zeros, and then I have 1 times 125, so this one is pretty easy. Then I will sum up all 3 of my terms. 5, 2, 16, 5, 1. Okay. 15,625 goes here. 15,625. Okay. With the x equals 1 example, I could kind of guess that it was around 2. With this one, I can't really see it just yet, so I'll keep going. I will add, the denominator is easier, 2,900. And I'll add the numerator. Let's see, these first 3 digits shouldn't change. Then the 6 and the 2 makes an 8. The 4 and the 5 makes a 9. And then now I can kind of tell that this is around 5. Again, I'm using some rounding strategies. If the denominator is 3,000 and the numerator is 15,000, that's pretty close to 5. Actually, that's equal to 5. So already now I can kind of tell that I'm on the right track. This is probably close to 5. I just need to prove that it is. To go between a fraction and a decimal, I like to use long division. So I'll put my divisor on the outside and my dividend on the inside. Then, well, going through the long division process, I would ask myself, does this number fit into 1? No. Does it fit into 15? Still no. 156? Also no. Also no with this one. So I just kind of have to figure out, well, how many times does this 2,900 go into this bigger number? Earlier, I kind of already figured out that it's around 5, and that was from rounding the numerator and denominator. So I'll take a guess, maybe 5 is going to work, and I'll double check with some multiplication here. Okay, cool. So this number is just below this one, which tells me that 5 is the correct number to start with. I will subtract out this 14,500 that I figured out from over here. And now I got to keep going though, because I want a decimal approximation. And the way to do this is I could add a 0.0 right here and bring down the 0. And for now, just kind of pretend that I'm doing a division problem where this goes into this number. And I'll just keep track of my decimal point the right way. So I'll keep the decimal point here, and it should show up above as well. Well, same thing. 2,900 times something gives me 11,890. And I'll cheat a little bit, as in I already know that the number is 4, so I'll pretend that I picked the right number. Oh, let's try 4. Let's see what happens. So I'll take 2,900, I'll multiply it by 4. And nice, it is right below this value right here. So I know that I can put a 4 in my quotient. Multiplying the 4 and the 2,900 gives me this number. And then with long division, now I gotta subtract. Okay, so I need to do the exact same thing as earlier, where I could have these placeholder zeros drop down if I want. And I guess I only really need one. And this 0 can drop down here, and whoa, it's exactly the same number. How many times does 2,900 go into 2,900? Well, that is exactly once. I can finish my long division, and I have a remainder of 0. So when I plug in x equals 2, I get exactly 5.41, no more, no less, and I have verified that 2 is the answer. In today's epilogue, I'll show how it might look to answer this question using a bit of technology. I really like using Desmos for my day-to-day math problems, where I'm not restricting myself to just doing it by hand. If I wanted to solve this on my own and I didn't know that the answer was 2, I would probably just write a function in Desmos. So I would write as it is, as the problem is, and I'd make it a function. And this allows me to plug in values and test them out. So I could test out f of 1. This plugs in a 1 in all of these x's. And earlier in the video, I was saying that this is about 2, and I decided not to solve for it. Turns out it's 1.9. And then I can try f of 2, and there's that 5.41, and it verifies my result. And at this point, I would be done. I could solve this problem in 30 seconds by just typing it in and trying out some numbers. In fact, I could even write y equals 5.41 and check when this curve crosses at 5.41. And it looks like if I plug in 2, I get 5.41. And oh, hiding over here, I could have also plugged in a negative 2 and gotten 5.41. Though the problem did state that x was supposed to be greater than 0 or positive, so that solution doesn't count. But it is pretty cool that the math allows you to plug in a negative 2 in all of these spots, and you also get the same number. Anyhow, we can use technology as well to verify our answers much more quickly than doing it by hand. Thanks again for tuning in, and we will see you in the next episode. Say bye!